Hi, this is Mr. Shumway. This video clip explains how to calculate roof distance. For example, if the width of a home is 21 feet, the peak of the roof is 10 feet above the ceiling, the roof extends 2 feet past the walls, the distance of the roof is, well, let's draw a little picture to try to explain what I'm talking about. So here's the width at the end of a house, and here's the roof. So this overhang is 2 feet, and this height is from the ceiling, you know, the height of the walls, up to the peak. So we want to find, if we're trying to buy shingles, we have to buy for this length and this length. It's a little bit longer than just straight across, just the width of the house. So let's figure out a little better. So using Pythagorean's theorem, we know that this side of a triangle is 10, and this side of the triangle is half of 21, which would be 10.5. Let's go ahead and add on the 2 feet out to the end here. So let's make our triangle be 10 by 12.5. So for Pythagorean's theorem, we can say that 10 squared plus 12.5 squared is equal to this distance here squared. So we have 100. So 100 plus 156.25 is 256.25, and if that's equal to x squared, then x is equal to the square root of that, which is really close to 16 feet. So that's quite a bit longer than the 12.5, so it probably makes sense to include that in our calculations so we get enough shingles. Let's do another one just for practice. You could try pausing this and doing it on your own and see if you come up with the same answer. This time this one's going to be 7. Half of 27 will be 13.5. So our triangle will be 15.5 by 7. Seven squared plus 15.5 squared, 49 plus. So add 240.25 plus 49 is 289.25. But that's x squared, so I have to take the square root to get x, and the square root of that turns out to be almost right at 17 feet. So that one's not a whole lot longer than 15.5, but it probably still makes sense to include that in our calculations.